Welcome to Module 6. It's all about programming, or the fundamentals related to the programming. What are the issues related to the programming? How you start doing programming. You will also know about the environment which you are going to do the programming, and the essential features which are required for programming. All those things we are going to discuss in Module 6. So the first topic in this one is essentials of program development. Program development steps. So in this session, we will only discuss program development steps, but we will discuss it extensively. Program development steps. These are not just applicable to doing C programming. This is a general topic. Which is applicable to programming. So you may do programming using C or Python or Java, doesn't matter. So these are the steps to be followed. So it will be useful for you not only in the first year, but it will be useful to you always. As a programmer, as a software developer, it will be useful to you. So program development steps. So the first one is data design. Determine the data to be used and organize the data using appropriate data structures. So data plays an important role. So actually program is nothing but data plus algorithm. So for what purpose we are going to write the programs? So basically we write the programs to manipulate the data. So that we get some information from the data. We manipulate the data. Now, whenever you want to manipulate the data, first you will have what is called as input data, and then you manipulate that data to produce the output data. In what way you are going to present that input data? So input data can be presented in different ways. It can be organized in different ways. It can be accessed in different ways. It can be manipulated in different ways. But data plays a crucial role, and the importance of data is increasing day by day. So maybe for say a program like adding two numbers, so it will be dealing with only three types of data items. One is the first input data item, second input data item, and then the output data item. That is some of them. But nowadays we are dealing with huge amount of data, streaming data. Whenever you are processing or whenever you are doing programming based on what is called as data that is obtained from say Facebook, Twitter, LinkedIn, etc. So we'll be getting huge amount of data, and that too the data you will be getting will be in the real time. So as and when data comes, you may have to process it. You have what is called as streaming data. So you have to process the data as and when it arrives. So it's a huge task. We're not going into all those details, but the point to be noted is the importance of data is increasing day by day. Next, procedural design. Write the algorithms. Okay, you have data, you want to manipulate the data. In what way? So that is nothing but the algorithm. You write the algorithms for manipulating the data. So after writing the algorithms, using any editor or integrated development environment of your choice, type the program. Okay, you have decided the data and you have decided the algorithms. So you have to choose appropriate editor or integrated development environment. Editor means which allows you to edit the programs. Editing means typing the characters, deleting the characters, inserting the characters, etc. That is nothing but the editor. But nowadays we are going with what is called as integrated development environment. That means What are integrated here? What are integrated? So while doing the programming, you have to type the program, compile the program, and then run the program. All those features are integrated or brought together. That is integrated development environment. So you will make use of integrated development environment for developing the programs. That means for typing the programs. So that means the editor will be part of this integrated development environment actually. So you'll be typing the programs. Okay. You will be correcting any errors, and then you will be compiling the programs. Again, you may correct the errors if necessary, and then you will be running the programs. So all those things will be doing in what is called as integrated development environment, or IDE. So after choosing appropriate integrated development environment and typing your program, compile the program. So you have to convert it into object code. In the process, you may encounter different kinds of errors. Those errors are to be corrected before executing the program. Okay, now correct the program. After correcting the program, execute the program. Okay, execute the program. Executing the program means you will be actually giving different sets of input, and you will be getting different outputs, and you will be verifying whether those outputs are correct or not. So give different sets of input and verify the output. So after that, document the program. So we have done fine. You have designed the data, you have written the algorithms. All those things are to be documented. Keep it in form, in soft copy or hard copy form. So everything which you have done is recorded. That is documenting actually. Everything you have done is recorded. It's not just about the program code, the data design, the algorithms, about the IDE, etc. if necessary. Okay, what are the errors that are encountered? All those things will be recorded. So that is nothing but the documenting the program. Next, data organization. Data organization plays very important role in program design. Programming design. Historically, the importance of data is continuously increasing, and the size of data is also increasing. As we discussed, size of data is also increasing. Programs may have to deal with enormous amount of data. For small and medium range programs, data can be organized in the form of appropriate data structures supported by the chosen language. So how do you represent the data? For small and medium range programs, that means whenever you have small amount of data, what you can do is you can use appropriate data structure supported by the chosen language. Supported by the language. So while designing the data, we usually don't think about the language which we are going to use, but having an idea about the language may help you in designing the data appropriately. But anyhow, after data design part, after data organization part also, you have to think about the support that is provided by the chosen language. What is that support that is provided? So that is important. So for complex programs, most of the data is stored in the form of files. So definitely you cannot just type the input while executing the program. So it will be in the form of files. So data is stored in the form of files. So data has to be brought from the files. And it has to be stored in appropriate data structure supported by the language. And then you have to manipulate it and maybe again represent it in the form of files. For large amount of data, definitely data has to be input from the files and data has to be stored as output into the files. So programming language chosen depends actually on the type of the data and how we want to access and manipulate the data. So you have to remember that point. So why you study any programming language means to know about the features. Now, when you collect the data, all the data, so you should think how to manipulate the data and what are the features of different languages which allows you to manipulate the data easily. So some languages have some features. So some languages will be suitable for some programs, so for some data manipulation. So you have to think about it. That's why we study different programming languages. Because if there is a language support, then manipulating the data is easy. If there is no language support, then manipulating the data is difficult task. For example, this telephone directory. So telephone directory is organized according to two fields, name and list of telephone numbers. It consists of two fields, name and list of telephone numbers. Now, let us assume two types of organization, data organization. So one is tell direct one, which is sorted by name field. So that means entire data is sorted by name field, and tell direct two, which is unsorted. So if it is sorted, finding the telephone directory, finding within the telephone directory the phone number of a particular person is very easy. So if it is not organized like that, if the data is not sorted by name field, that is in case of tell direct to, okay. So in that case, it is difficult. It is very, very difficult. So the data is sorted. Then finding the phone number of a particular person is very easy. Otherwise, it is very difficult. Why? Why is it so? So it is tell direct to only. Some spelling mistakes, note it. Okay, that means that is not sorted one. That's all. So why it becomes easy to manipulate the data, or why it becomes easy to find the phone number if data is organized in a sorted order? That means in what way the data organization, in what way the data structure is influencing our algorithm complexity, is influencing our procedure complexity, algorithm complexity. In what way? So if it is in sorted order, then what you can do, or what your algorithm can do, so just find out the first letter of the name of the person, and because it is in sorted order, you can try to go to approximately that page. Say it is K, so you can approximately go to that page. After going to that page, we can just try to open it in the middle, because it is K, approximately in the middle. So you try to go to that page. Okay, you will go to a particular page. After that, what you can do? So if that page has all the names starting with K, then you consider the second letter. And based on the second letter in that page, you can go either to the left or to the right. So these process can be easily repeated. Maybe after 4-5 searching for 4 pages, 5 pages, or maybe maximum of 10 pages, you will be arriving at the name if it is available, and then you can give the phone number. Otherwise, if it is not sorted, then what happens? You don't know where it appears. So the only procedure you have is start from the first name, whatever it be, and then search sequentially until you either encounter the name, or you reach the end of the telephone directory and you don't find the name. So you can imagine the complexity. So that's why data organization is very, very important. You will study a separate subject on data structures, but it's not about just the data structures which you are going to study, study as a separate subject, but you should also know about the support provided by different programming languages. In general, you may study about data structures, but finally everything has to be represented in the form of a program written in a particular programming language. So you should bother about the support for the data structures in a programming language. That's what is important. That's what is important. So the data can be singular data or homogeneous data. The data can be singular data or homogeneous data. Just a minute. Data can be singular data or homogeneous collection of data or heterogeneous collection of data, and also unorganized data. Singular data means simple variables. Suppose you are writing a program to add two numbers. So A, B are the two numbers, C is the output, which stores the sum of the two numbers. So such data is singular data, and such data can be easily represented. But only thing is you have to choose appropriate names. Instead of say choosing A and B, so better you choose first number, second number, and then for storing the sum, say the name of the variable be sum. So it's better you choose appropriate names. It's better to choose appropriate names. So singular data can be represented in the form of variables and constants, and using the data types, basic data types supported by the language. Basic data types supported by the language. If we have a collection of data, decide whether it is homogeneous or heterogeneous. Decide whether it is homogeneous and or heterogeneous. So there will be different support by the programming languages for both homogeneous data and heterogeneous data. For homogeneous data, actually cut across all the languages, there will be a data structure called as array. Using array, you can represent the homogeneous collection of data. If it is a heterogeneous collection of data, then you will have a support for what is called as record of data. So in the form of structures, unions in case of C language, maybe in other languages, but C++, Java, etc. All those things also support structures. So there will be different support. So you have to use that support. Okay. For easy access, we may use sequential data structures indexed by integers. Whenever we have homogeneous collection of data, you can have these data structures which support indexing by integers, so that accessing them is easy. Okay. Sometimes we may not be in a position to access the data using integers. Maybe you have to use what are called as strings. So accessing here means indexing here means, so if roll numbers are there, if an array is there, say, so you can use roll number of 0, roll number of 1, roll number of 2 to get the actual roll number. So that is here indexing is 0, 1, 2, which you are using. Okay, roll number of 0, roll number of 1, roll number of 1. So usually what is done is it will be like this. Roll number of 1, roll number of 2, number of 1, roll number of 2, like that, or in general roll number of I. So that is here I is indexing. Now sometimes you may not be in a position to use integers as indexes. Sometimes you may have to use strings. But in a language like C, you cannot use strings as indexes. But in a language like Python, there is support in the form of what are called as dictionaries. So that means you have to choose appropriate language also. So data can be heterogeneous, that means record of data, say student data. Student data consists of roll number, which can be integer or real, and then name, which is generally a collection of characters or string. Similarly, the address can be a string, and then marks. They can also be again numeric type. They can be numeric type. So maybe grade again, which is of type string type or character type, like that. So you will have different data which is of different types. In the case of roll numbers, all will be of same type. So if they may be integers or they may be strings, but all will be of same type. All will use the same representation. Whereas in the case of record of data or heterogeneous collection of data, the data that is present in that record can be of different data types. Okay, homogeneous data, heterogeneous data, and also nowadays we are dealing with what is called as streaming data. That means data is coming, something like a stream, water streams. Might have observed the water streams. So similar to that, so data will be continuously coming. So that data you may have to capture and manipulate if necessary, or extract some information from it. Okay, that is regarding the data design or data structures or data organization. We have not gone into the details of the data structures, that is beyond our scope, but we discussed that data is important and data representation is very, very important, because your algorithm complexity depends on the data organization. Next is procedural design. That means how do you manipulate the data? Okay, you have stored the data in appropriate form, but finally what you have to do, you have to manipulate the data to extract the appropriate information. So that is done using what is called as procedural design. Before program is written, we have to write algorithms to manipulate the data. Maybe for simple programs, you can directly go and write the programs. Simple problems. You can directly write the programs. But usually for complex things, it's better you write the algorithm. And algorithms can be written at two levels: conceptual algorithm and implementation level algorithm. Usually for simple programs, you go with simple problems, you go with program directly. For medium size problems, you can directly write what are called as implementation level algorithms. That means you can have an idea about the language in which you are going to write the programs, and based on that one, you can write an algorithm which can be easily converted into the program in a particular programming language. But still, it is independent of that programming language. But you can see the data structures which you choose, the way data is organized, and the way you write the algorithm will be based on your idea about the programming language. So it is more close to the program. Okay, that means you should be able to easily convert this algorithm into program. So that is implementation level algorithm. So when the logic is complex, you start with what is called as conceptual algorithm. You don't try to go to the minute details, but you concentrate on the concept. Okay. So at a higher level. So what is the task you are going to do? So you write at a higher level. So writing the program. So you have chosen appropriate data structures and you have written the algorithms. Now translate those data structures and algorithms into the features that are supported by the programming language, into the program of written in a particular programming language. So what are the features? Those features you have to choose and then represent the data and also write the code for the algorithms. So use proper indentation and comments. Write the program incrementally. Don't try to write the entire program at a time. whenever it is medium size complexity 1 or large complexity 1. So don't write it at a time. So write it incrementally. That means you write some code, one module, that means you can say some code, check it. Okay, next again you add the code and then again check it. So that's how you have to proceed. Write the program incrementally. So few steps at a time, write, check whether everything is working fine or not, like that. So optimize the code also, try to ensure that the code runs quickly and use appropriate features of the language. Compiling the program. Okay, you have written the program. Now what you have to do? You have to compile the program. That means you have to convert it into the machine code or object code which the computer understands. How do you do it? By invoking appropriate compiler or interpreter. So actually this compiler and interpreter will be part of the integrated development environment. So using mouse or by using some key combinations of the keyboard, we can compile the program. So compiler converts the source program to object code. And definitely sometimes you get errors. So those appropriate error messages are generated by the compiler, and believe in that compiler. Okay, most of the times what we do is compiler generates error message, but we don't read it carefully. We try to find the error on our own. So we get irritated and we try to find the error on your own. Please don't do it. Compiler is written by highly intelligent people, so it generates appropriate error message. So try to understand that error message and then correct the error. It also provides you information about where the error is, okay, line number, etc. So make use of it. But sometimes the error may not be on the line which the compiler is showing. It may also happen, and also some errors may be hidden. So you correct some error, you will get several errors again, because those errors are covered by the current error. So it may happen sometimes. Okay, but if you continue to do it incrementally, then it's easy. So sometimes if you correct one error, some other errors, 5-6 errors may vanish. Okay, this you will learn by practice, but try to identify the errors. Don't get discouraged when you get errors. Okay, software is highly flexible, so you can easily correct them. It's not hardware, not a painting. You commit a mistake, gone. So it's not like that. So software is highly flexible one, so correct the errors. So try to just go through the program and first correct it. The types of errors. Okay, the types of errors which may be encountered. The types of errors are syntax errors, logical errors, runtime errors. Syntax errors, logical errors, runtime errors. These are the three kinds of errors which you may encounter while compiling the program and also while running the program. First set of errors are syntax errors. So syntax errors are those which are related to how you write the statements, whether you have written in correct way or not. Okay, that is important. Suppose if it is adding two numbers, then you should write, say, C equal to A plus B. So this is the correct syntax. Now suppose if you write C equal to A B star AB plus say, AB plus. This is wrong syntax. You cannot write like this. So the operator should be in between the operands. So this is correct. This is correct. But operator here is after the operand. So this is wrong. So these are the syntax errors. How you write the statements? Syntax errors. And one advantage is compiler generates error messages which are related to the syntax. Compiler finds the syntax errors. Compiler finds the syntax errors. Remember, logical errors, compiler will not find. Even it provides little help regarding runtime errors. The compiler can find the syntax errors. Compiler can find the syntax errors. So find the syntax errors, correct them. Compiler recognizes only syntax errors. Typical examples are invalid identifier, wrong number of operands. So you have to write A plus B. Suppose accidentally you forget to type B, A plus. Or you in C language, every statement, declarative and executable statement should end with the semicolon. To forget semicolon. So all these are compiler related messages, compiler related errors, or that is syntax errors, which can be recognized by the compiler. Sometimes you have to follow the principle of cause and effect to identify the errors. Cause and effect. So what you see is actually effect. What you see is actually effect. But the reason for the error may be somewhere else. That is actually called as cause. So try to go to the cause of the error. Try to identify the cause of the error and correct it. That's what you have to do. So compiler generates error messages. So you can use compiler error messages. Logical errors. Logical errors are those which are errors in the programming logic itself. So that means you have written the program in a wrong manner. Compiler will not generate any error message. Suppose again, if you consider simple one, C equal to A plus B. So if you want to add two numbers, this is the correct logic. Okay. Now you want to add two numbers, but accidentally or whatever may be the reason. So you type like this. Now this is also syntactically correct. This is not a syntax error. But you will get the wrong output. You will not get the sum of the two numbers. You will get the product of numbers. So that means this is a logical error. So you expect or you are supposed to find the sum of the numbers, but accidentally instead of plus you have used star. So you are getting the product of numbers instead of sum. So that is logical error. So compiler will not generate any error message because compiler doesn't know what you want actually. Compiler will not know what you want. Compiler bothers only about the syntax. So logic is left to the programmer. It is up to the programmer. To correct the logical errors. So these are costly. Logical errors are costly. Syntax errors usually can correct, but logical errors are costly. If you write the wrong logic, you will never get the output, required output, expected output. So debugging can be used to correct logical errors. Debugging. That means finding the bugs. Bug is error. Okay. Debugging can be used to find the logical errors. How to do it? By different methods. So there are different methods of debugging the programs. So one is brute force method. One is called as brute force. Okay. Brute force method. Forcing something like a brute. Okay. Brute force method. So in programming terms, it is actually, you can say, inserting different printf statements or inserting printf statements at different points in the program. You will try to identify where the error is. So suppose now you are getting the wrong output. So you are calculating the C value and then you are doing other manipulations. So say D equal to C plus 5, E equal to C plus D plus 23, something like that. You have sequence of programming language statements. So final output you are getting wrong. Now where is the problem? So what you can do? You can print the value of C, check whether it is correct or not. If it is correct, then print the value of D, check it. Like that you can insert different print statements at different points in the program and you can find the errors. There are automated tools also. Integrated development environment has some support which allows you to execute one instruction at a time, and then watch the values of variables after each and every instruction. That is called a single step mode. That will be available in different IDE environments. So you have to find out how it is supported. Okay. So using those features supported by the integrated development environment, you can find the errors. Runtime errors. So those errors which occur during the runtime. These are unexpected errors. These are the errors that occur during the execution of the program, but these are unexpected errors. That's why they are called as exceptions. They are exceptions. They are not expected. Okay, one example is divide by 0. So you are performing, say, addition, subtraction, division, multiplication of the numbers. So unexpected thing in that case is division by 0. The problem with the division by 0 is, so computer doesn't know how to perform it. Computer doesn't have anything like infinity. It can store value up to some number, but infinity it cannot store. What is infinity? It is difficult to define. So divide by 0 is an example of runtime error. So some programming languages support handling of these exceptions. There will be a support. So you have to use that support. Suppose like Java, Python, etc. have lot of support. So C doesn't have any support for these exceptions. Maybe the advanced versions, latest versions of C may have some support, but standard versions, ANSI C standard, etc. they don't have any support. So if there is a support, use the support of that language. The common errors, you can see statement missing semicolon. So these are the common errors. They are not the only errors. You may make thousands of errors. So different kinds of errors will be there, but these are some common errors whenever you are writing small programs. Statement missing semicolon, you forget to declare the variable. Also we'll discuss functions. Functions also you don't declare it, but try to use it. Library function, some library function you will try to use it, but it's not declared, it's not defined. Wrong number of operands, a plus b, but you forget to give b, a plus, you write just a plus. Okay, like that. Wrong number of arguments to your function. For a function you have to pass arguments, but you don't pass appropriate number of arguments. Overflow error, that means the value cannot be stored in that memory location. Divide by 0, infinite loop. Infinite loop means program will continue to run. It will never come out. It is infinite loop. Left hand variable missing. That means whenever your program returns something, there should be what is called as left hand variable that may be missing. The LHS should be a variable, means the address should be present on the left hand side, not the constant. So testing and debugging. Testing is the process of giving proper input to the program and checking whether we are getting the correct output or not. So testing is nothing but choosing the different sets of inputs and running the program and getting the output. Then after that, check whether the output is correct for that input or not. So that is testing the program. So you have to test with all possible typical inputs, particularly the so-called boundary values. Okay. So it depends on the program, but remember, testing the program is a difficult task. So you have to choose all possible typical inputs and check it. Debugging is the process of correcting the errors. So the purpose of debugging is to uncover the errors. Uncover the errors. Cover means find the errors, not to ensure that there are no errors. It is actually, the purpose is to find the errors. So it is in a sense destructive. Or negative. But still, you have to do it. So testing is usually done by the software testers who are actually separate people. They don't develop your program. The program will be developed by somebody else. It will be tested by somebody else. Those people are called as software testers. Because as I already told you, it is a destructive process. Its intention is to find the errors. So sometimes we may take it negative, and the program developers doesn't do this testing extensively. Preliminary testing they will do, but they don't do extensive testing because they may not find the errors. It is something like in Telugu kaaki pilla kaaki muddu annadu. So we become so close to our program that we don't see any errors. So usually, even if a child is not good, so mother will not find any problem with the child because the relationship between them is so close. The mother fails to identify the problems with the child. So similarly, program developers are so close to the program, they can't find the error. So it is given to a separate people called as software testers. But debugging is usually done by the people who are involved in the program development. Testing can be done in two ways: verification and validation. Maybe this is too difficult for you to understand at this point of time. But in simple terms, verification means ensuring that the program itself is correct. That is generally done by a mathematical process. To ensure that the program is correct for all the possible sets of input. So that ensured by mathematical process, not by giving input. So validation is giving several sets of input and getting the outputs and ensuring that the outputs are correct. That is validation. Verification is a mathematical process. Validation is, which we generally do is give the input, check the output. Testing is a continuous process. Testing can be done at different levels. Usual statement level, like C equal to A plus B. What is the error in that one? After that, that program level, individual function level, and then the program level. And this program which you have written is not the only program. Your team members have also written some programs which are to be combined. So at that level also you have to do. And the software can be only part of the system. Software can be only part of the system. Suppose you have a biometric machine. So you have a machine, hardware part is there. So you press the, you put your thumb, So the role of the software there is to take your thumb and verifying it with other thumb impressions which are already stored. Okay, but it's not the case, it's not the only thing. Whether the sensitivity of the machine is also important. You are pressing with your thumb. Okay, now is it able to scan it? Is it able to sense it or not? Sense it or not? Okay, is the memory sufficient to store the thumb impressions of several people? Because it has to be verified, compare. So system level testing. So software can be sometimes only part of the system. So as discussed previously, debugging is done by people who are involved in the development, and it can be done by brute force method. It can be done by inserting different print statements. So it is done manually. Debugging is considered as complex task, and it is recommended to use prevention strategies. So how do you reduce the complexity of debugging? By writing the program correctly. Ensure that you write the program correctly. So like that you can ensure. So this is regarding the program development, essentials of program development, So we learned how to develop the program, starting from data design to executing the program and then documenting the program also. We didn't get into the documentation details, how to do the documentation, but for the time being, you can just remember everything you do should be recorded as part of the document. Thank you. Best of luck.